All right, so chapter 1, section 3, it's split up into two sections. So we're going to learn about algebraic expressions and also combining like terms. So first we're going to start with verbal expressions. So verbal expressions can be translated into algebraic expressions by using the language of algebra. So here's some keywords that we see that mean addition. So some of those words are plus, the sum of, increased by, total, more than, added to. We have some common words that we see for subtraction. So minus, the difference of, decreased by, fewer than, less than, subtracted from. Multiplication, we could say times, the product of, multiplied by, of, or each. And division, divided by the quotient of and per. So these come in handy whenever we have word problems. In our examples in the notes and in the homework, it'll give you like a verbal expression, like it'll say the math problem in words, and we have to put it as like an actual math problem. And then it'll also be the opposite, so it'll give us like a problem like with numbers, and we have to put it into words. So let's look at some examples. The difference of a number p and 36. So what does difference mean? Subtract. So the difference of a number p and 36, we would say p minus 36. Two, 15 more than the number q. So what does more than mean? Addition. So we would say 15 plus q. 3, the product of 10 and a number r. What does product mean? Multiply. So 10 times r. 4, the total of a number y and 9. What's total mean? Addition. So y plus 9. 2 more than 4 times a number. So what does more than mean? Plus. And what's times? Multiply. So we have 4 times the number, so 4 times n. So we could say 4n. And then 2 more than that, so 4n plus 2. So for this one, you just have to be careful that you're multiplying the right stuff. It's 4 times the number, and then you're adding 2 to it. So if you had like n times 2, that would be wrong, because it's 4 is what's being multiplied to n. And when it just says a number, you could say n, you could say x, you could say y, whatever variable you want for that number. Yes?
Number 2, wouldn't the 15 be behind the q?
This is the same thing as saying q plus 15. They're the same. So you could write it that way. For addition, it doesn't matter the order. The quotient of 5 less than a number and 12. So the quotient is what? Division. We have 5 less than, what's less than mean? Subtraction. How would I write 5 less than a number? So we're taking away 5 from that number, so it would be x minus 5. So if I said 5 less than 6, that would be 1. So 6 minus 1, or 6 minus 5 would be 1. So the 5 has to come second. And then the quotient, what am I taking the quotient of? 5 less than a number, so this whole thing, and 12. So 5 less than a number, x minus 5, and 12. So I could say x minus 5 divided by 12. So just be careful, because I'm taking the quotient of this whole thing here, 5 less than a number, and 12.
Doesn't and mean plus? Or no?
This is just saying the quotient of these two numbers. So I could say the product of 4 and 3. The and wouldn't mean plus there. So you just have to be careful with the wording. Any questions yet? Alright, so looking at a word problem. You start with $20 and save 6 each week. What algebraic expression models the total amount you save? So I start with $20 and I save 6 each week. What does each mean? What am I doing if it says each? Multiplication. So I'm going to multiply 6 to what? To what?
To 7 per week.
I'm talking about the week, yes. But it doesn't say like days specifically. So it wouldn't be 7. X. The week is going to be my variable. I'm going to call it W. You can call it X, whatever you want. I'm just going to call it W for here. Because I didn't want to put X again, because I put X for the multiplying part. So it's 6 times W. $6 each week. And then how can I write that I started with $20? What do I do? Plus 20. So I could say 20 plus 6W, or I could say 6W plus 20. Either way would work. They're the same thing. So both of these are the right answer. Any questions here? Alright, for the next page, I'm doing the same thing but opposite. So I'm taking the problem and putting it into words. So how would I write A in words? What sentence would I say? So what's a word that I can say that's multiply? Times. What's a word I can say that's equals? I don't know if this was on our list, but you can say equals. Equals works. Equals. Or you could say is. So for this one I could say 6 times. How would I say x? Because in my other problems I didn't say x. What did I call it? A number. 6 times a number is 72. What's another word for multiply? Could say multiply. We just use times. What else? The product of. So I could say the product of 6 and a number is 72. So more than one way you could say this. So there's more than one right answer. Let's look at B. How would I say plus? What's another word for addition? And? What's another word? Sum of. Any other words? Total. What do I say for n? How do I say that in words? N. A number. So I could say a number and 15.
Do we have to write out, or can we just put the number 15?
We could just put the number. A number and 15. Can I say equals? is 91. So a number and 15 is 91. You could say the sum of a number and 15 is 91. You could say the total of a number and 15 is 91. So again, more than one way to do this. There's more than one right answer for these. Any questions? All right, next we're going to be moving on to combining like terms. So some important vocab that we have, which we also saw this in 1.1, is a term is a number, a variable, or the product of a number and one or more variables. So here, if I had, I'm going to write an example up at the top. Let's say 5a plus 2b plus 6. This is a term, this is a term, this is a term. So terms are separated by plus or minus signs. So term, term, term. Coefficient is the numerical factor of a term. Factor is another word for multiply. So in my example up here, the blue one that I wrote up top, what's a coefficient up here? What's a number that's a coefficient? 5 is a coefficient because it's being multiplied to a. What's another coefficient? 2 is also a coefficient. What are my variables that I have in this example up here? A. And what's another variable?
X.
Do I have x in my problem up top?
Oh, not up top, no. B.
B.
I was looking at the bottom one.
I'm just talking about the top one for now. And then in the top one, what is a term with no variable? Well, constant is a term with no variables. So what's a constant in my top equation? 6. So coefficients are numbers that are being multiplied to your variable. Constants don't have a variable. Do you guys have any questions here? All right. So next we're going to look at like terms. Like terms can have the same variables to the same powers, and like terms can be combined. So looking at my like terms here, I see I have a 2x and a 5x. These are like terms because they have the same variable here, x and x. If I had 6x and 5y, these are unlike terms because they're not the same variable. X and y are different. I can combine like terms. I cannot combine unlike terms. So again, for the second one here, I have a and a. So these are like terms. Even though the coefficient's different, the variables are the same, and that's what makes them like terms, when the variables are the same. Here I have y and y squared. These are unlike terms. They're not the same thing. Even though they're both y's, one of them is y squared, so these are unlike terms. I cannot combine these. And then for the third one, I have xy squared and xy squared. These are the same thing, so I would be able to combine these terms because the variables are the same. So the variables have to be the same for you to combine them. It's like saying if I had 1 apple and 6 apples, how many apples total do I have? 7. If I had 1 apple and 4 bananas, how many apples total do I have? I can't add those two together because they're different fruits. So they're like different things. So we cannot combine unlike terms together. So like terms have the same variables raised to the same powers. So here I have x squared and x squared, so these would be like terms. These would be like terms because I have y to the third power times z and y to the third power times z. Even though this one in the middle here has a y and z, it's not y to the third power times z, so it's an unlike term. It's not the same. So looking at this example, let's combine our like terms. When you have the same variable, you just add the coefficients out front together. So what's 3x squared plus 5x squared?
8x.
Awesome, 8x squared. 8x squared. So the x squared stays the same, the variable stays the same, you just add the numbers out front. Now let's add 9y to the third power times z and negative 4y to the third power times z. What would those be?
5y cubed z.
Awesome. 5y cubed times z. I like that you said cubed. So cubed is the same way of saying y to the third power. And then can't add anything to the 2yz, so that just stays the same. So this is the simplified expression here. We just combine the like terms to make it simplified. We have a little question on the bottom. Do you think 7x squared and 3y squared are like terms?
No.
Why not?
Because x and y are different.
Awesome. Even though they're both squared, this is x and this is y, so they are not like terms. Do you guys have any questions here? Right, next page. We need to combine like terms. So what's a like term with 7x squared? Negative 4x squared. So what's 7x squared minus 4x squared? Perfect. 7 minus 4 is 3. So 3x squared. Next, I have 3y squared. Well, do I have a like term with 3y squared? 2y squared. What's 3y squared plus 2y squared?
5y squared.
Awesome. 5y squared. So this is my answer. Do I have any like terms with 3x?
Yes.
What?
4x.
Negative 4x. So what's 3x minus 4x?
Negative x.
Awesome. Negative x. 3 minus 4 is negative 1. And we know we don't have to write a 1 in front of our variable. Because if you said 1x, if I just had 1x, that's the same thing as just saying x. But we just don't put the 1. All right, our next term here is 2a. Do I have any like terms with 2a? Nope, so I would just put plus 2a. That's my answer. Any questions here?
Go back up.
What do you think we have to do first here in order to combine like terms? Distribute. So I want to distribute this negative sign, and I want to distribute this too. So I want to get rid of those parentheses that I have in my problem. So I need to distribute. So I have negative 3k. Don't forget to multiply that negative to the m also. So this would be negative m plus, what would come next? 2k. And then what's 2 times negative 4m?
Negative 8m.
Awesome, negative 8m. So once I distributed and got rid of my parentheses, now I can combine like terms. So do I have any like terms with negative 3k? 2k. So it's negative 3k plus 2k. Negative k. Alright, and then next I have n. Do I have any like terms with negative n? Negative 8n. How do I combine negative n minus 8n?
Just add them.
So it's negative n minus 8n.
Negative 9.
Negative 9n. Any questions here? Ready for the next one? Alright. So first I have negative 7ab. Do I have any like terms with negative 7ab? Yes. Negative 3ab. So it's negative 7ab minus 3ab.
Negative 10 AB.
Awesome. Negative 10ab. Next I have 6b. Do I have any like terms with 6b?
Negative 4.
Negative 4b. So it's 6b minus 4b. Anybody? Yes.
Plus 2B.
Plus 2b.
Oh, and there's another 3AB.
And there's another 3ab. So that goes with this one here. So it's negative 10ab minus 3ab.
Negative 13AB.
Awesome. Negative 13ab. So negative 13ab plus 2b is our answer. Any questions here? Last one. Combine like terms. So what like terms do I have with 7x squared? 2. Negative 4x squared. So what's 7x squared minus 4x squared? What is it? 3x squared. And what about 3y squared? Do I have any like terms with 3y squared? 2y squared. What's 3y squared plus 2y squared? 5. So 5y squared. That's our answer. Any questions about the notes today? So we did a lot. We turned words problems into actual problems with numbers. We did the opposite, so we turned problems with numbers into sentences, and then we also combined like terms. So the homework is all of this in one.